Alright, this screencast is going to explain to you how to do valence electrons. So valence electrons are really important because these are the electrons involved in bonding. And these are the outermost S and P electrons. And this is why short form electron configuration works so well for us, is because it allows us to see what the outermost electrons are. So the electrons that are furthest away from the nucleus are the ones that are most easily moved from one atom to another or shared by another atom, which are the two predominant forms of bonding. So we're going to start with sodium as an example. So sodium is here on the periodic table. So I'm going to write short forms. So I'm going to go back to, since this is 11, I'm going to go back to neon. And I'm going to do 3s1. So this one's pretty easy. It has one outermost electron, so it has one valence electron. Okay. My next example, I'm going to jump to chlorine, so a little further out my row here. Okay. So for chlorine, I have to go back to neon as well. And if I'm marching from neon, which is 10, I'm going to go through this 3s2, and then that's going to take me out to 3p5. So I'm going to add both the S and the P, so 2 plus 5 is going to give me 7 valence electrons. Okay. So as I continue on, my next example is going to be chromium. Okay, this is element number 24. So this is the first element that I'm going to look at that is in the D block. So I'm now in my 4th row, so I have to go back to argon for my short form. And then I'm going to do 4s2, and then I'm going to do 3d, counting over 1, 2, 3, 4. So my outermost energy level is the 4th. So you might remember from the crazy diagram of orbital notation that the D's are sometimes higher in energy, but most of the time they're lower in energy, so they are closer to the nucleus. So these are the only 2 valence electrons. So I'm not ever adding the D's into that. You're going to see later that the D's do have some influence on bonding, but they're not considered valence electrons. Okay. And then the next one I'm going to jump to is tin. So tin is going to be all the way down here at element number 50. So because I'm 50, I'm going back to 36, and then I'm going to jump to 37. So I'm going to do Kr, 5s2, 4d10, 5p2. And I will jump that back up here, so element number 50. So again, my valence electrons are my outermost S and P electrons. So this is going to be 2 plus 2 for a total of 4 valence electrons. Okay. All right, I'm going to stop there. The next worksheet, I'd like you to think about, I know not everybody has the ability to print, but I'd like you to think about folding this in half, and I just want you to do the first 1 through 10, looking at short form electron configurations, and then I'd like you to stop at that point and watch the next video.